Next, page number 44, question number 3. Already this was given to you as homework, but I have seen many of the boys have not done this. So here shows a cross section of the wire carrying a current into the plane of the paper. Into means the current is down into the page. So how will be my field lines are moving? Okay, the field lines are moving in a clockwise direction. Sketch a magnetic field due to the current in the wire. The detail of the sketch should suggest the variation in the strength of the field. Shows the direction of the field with an arrows. So we know that with the help of the compass, draw it very neatly. Draw at least 2 to 3 circles very close to the wire and some circular field moving away from the wire. Draw it neatly. Okay, show the spacing. As you move at the field line away from the wire, the field strength decreases. So the current is into the page. The field lines are going in a clockwise direction. Okay, the field lines are going in a clockwise direction. Now part B shows the part of the model of a DC motor. A loop of wire ABCD is placed between the pole of the magnet. The loop is free to rotate about the axis. There is a current in the loop in the direction indicated by the arrow. So draw to show the direction of the force acting on side AB and CD. We know that the current, the magnetic field is from north to the south, and at the part DC, the current is going up into the like outward, and in part BC, the current direction is going downward. Okay, so when the current is going out here, the force is acting at the part DC is up, whereas at BC it is down. Okay, using your left hand rule. So we will draw an arrow here. It is pointing in an upward direction, and here it is pointing in a downward direction. Show it very clearly so it can be seen. Now, with the loop in the position, explain why the force on AB and CD causes the loop to rotate. So the force in the AB and BC, why it causes to rotate? What is the reason? Here, the force on AB and CD are in opposite direction, so they causes opposite direction. Force on AB and CD are in opposite direction, which causes the coil to turn or produces turning effect. Now the end X and Y are the loop are connected to a battery using the brushes and a split ring commutator. State why a split ring is used. As we all know that the function of the split ring is to reverse the direction of the current in the coil every half turn. So why the split ring is used? To reverse the direction of current in the coil every half turn, so the coil continue to rotate in same direction. Means if it is rotating in clockwise, it should continuously rotate in clockwise. If it is in anti-clockwise, it should rotate in anti-clockwise. Now number 4, a student want to demagnetize a permanent bar magnet. She suggested this step: Place the magnet in a long coil. Switch on the large alternating current in the coil. Switch off the current. Reverse. Remove the bar from the coil. State and explain whether the step will always be able to demagnetize the coil. Not always, we can say. Would not be effective. Would not be effective to demagnetize the magnet. Okay, we need to demagnetize the magnet need to be pulled out when carrying an alternating current. So this method is the effective method to demagnetize the magnet. Shows a coil supplied with current using a split ring commutator. State and explain any motion of the coil. So when the current is passed, so you need to explain what happened, how the coil will move when the current is passed through the coil. A force is said to be produced. A force is produced which makes the coil to rotate. The coil rotate in clockwise direction every half turn. The current in the coil is reversed. Okay. Now the coil in the figure 9.1 consists of 3 turns of the coil. The magnetic field of the magnet M with a current 2 ampere in the coil experiences a turning effect. So for example, here the coil is there and there is a supply. The current which is being supplied is 2 ampere, and here we have 3 number of turns of the coil, and it is placed in a magnetic field. Let the magnetic field be M. Okay, and there are 3 turns of the coil and the current passing through it I is equal to 2 ampere. So due to that a coil is experiencing a turning effect. The number of turns is 3. The current in the coil is this. The magnetic field is M. The turning effect is T. Now the number of turns of the coil remains same. But now you are increasing the current to 8. You are increasing the current from 2 to 8. So the magnetic field strength is same. So here we are keeping the magnetic field strength same and the number of turns of the coil is same, but increasing the current. So if you increase any one of them, the turning effect will be greater. So here what happened, the turning effect will increase by 4 times because you are increasing the current to 2 plus like 2, 4 times we are increasing, isn't it? No, 4 into 2 is equal to 4 2s are 8. So we are increasing the current by the ratio of 4. Now here we kept the current same as it is in the second part and third part, and the magnetic field as it is, but by increase the number of turns by 6. So we are increasing, it is 2 into T, because as we know that 3 into 2 is equal to 6. So the turning effect will be double. But now the number of turn is same and the current is also same, 3 and 2, but the magnetic field is reduced by half. is reduced by half. So obviously the turning effect will also decreases by half. So the answer is T by 2.